Okay, here's another one of those problems where you're going to have one of the products in the solubility equilibrium expression present in the initial concentration. This problem says we've got some sodium phosphate, and sodium phosphate is completely soluble, so it'll break up into 3 sodiums and a phosphate. If the initial concentration of sodium phosphate is 0.56 molar, then I got 3 times that for sodium ion and 1 times that for phosphate. So if the magnesium phosphate is our insoluble compound, notice I've already corrected this in your worksheet. It will form an equilibrium where it makes 3 magnesium ions and 2 phosphates. Now, in the initial concentration, I have no magnesium, but I do have 0.560 phosphate. Everything else kind of works out the way it normally does, though. The change for magnesium ion is plus 3x. For phosphate, it's plus 2x. Now, at equilibrium, I'll have 3x for magnesium, and I'll have 0.560 plus 2x for phosphate. Now, let's sort out what the molar solubility is by using the equilibrium expression. Let me put in the KSP, and that'll be equal to 3x quantity cubed times 0.560 plus 2x quantity squared. Now we got a little problem here. If we leave this x in this parentheses, we'll end up with a really difficult to solve 5th order polynomial. And so we have to make an assumption that says x, in fact, 2x is very, very small compared to 0.56. And so let's try that out. Let's see if that works. So I get 1.05 times 10 to the negative 24th. Let me go ahead and cube everything. So 27x cubed times 0.560, and that needs to be squared. What's left then is I get 1.05 times 10 to the negative 24, 27x cubed times 0.3136. Finally, or moving on, I get 1.05 times 10 to the negative 24, and that's equal to 8.467 x cubed. Dividing both sides by 8.467, I get 1.29 times 10 to the negative 25th. That equals x cubed. So that means that x equals 4.99 times 10 to the negative 9. Now again, was it small enough? Was 4.99 times 10 to the negative 9, even when I double it, I get essentially 1.0 times 10 to the negative 8. And that's really, really small compared to 0.56. So the assumption is valid. And so now I know the molar solubility when there's some phosphate present. Okay.